Hi everyone. Today we're going to talk about session 7.8, Introduction to Differential Equations. So here is the big idea. Many real-world situations can be modeled with functions that are defined in terms of differential equation. So we will learn how to solve the simplest of these equations by rearranging them and integrating both sides and find the solutions. So after you finish Calculus II, you can take the linear algebra and differential equations. Then you will see how to solve more kinds of differential equations. Okay? Big skills. You should be able to solve separable first-order differential equation. So we only learn how to solve this kind, separable first-order differential equation. So what is a differential equation? A differential equation is an equation that contains an unknown function and one or more of its derivatives. So for example, here, our unknown function is like y, okay? So the first, you can see this equation, it contains the independent variable x and the dependent variable and the derivative of y, okay? So the differential equation is like equation contains the derivatives. Okay, and next one you can see we have also y prime here, so it's a differential equation. Next we have the y prime plus 4x, and then this is also differential equation. And the next one you can see we have the second derivative. Okay, so this is also a differential equation. What is the order of a differential equation? It is the order of the highest derivative that occurs in the equation. Okay, so for example, here you can see the first example, we have the first derivative. So this is actually first order. Okay, and then next one, we also have first derivative. Okay, so it's first order. And next one, we also have, first derivative. And then the last one, you can see the highest derivative is the second derivative. So this is second order. Let me ask you like one more example. Let me put it here. So if we have like y prime to the 7 over x cubed plus sine y times plus xy equals 2. So if we have this example, what is the order? Is the order 7? No, the order is the order of the highest derivative. So in this case, the highest derivative is the fifth derivative. So this is actually fifth order differential equation. Okay, then a solution f is called a solution. A function f is called solution of a differential equation if the equation is satisfied when the function and the derivative are substituted into the equation. A differential equation together with the appropriate number of initial condition is called an initial value problem. So actually we learned some example before. Do you remember in the application problems, we talk about the one-dimensional motion. We have displacement, velocity, and acceleration. Okay, given the acceleration, when we integrate the acceleration, we will get velocity, right? But we will actually get antiderivative with a constant c. Okay, how do you find the c? You plug in the initial velocity in it to find the c, right? And then when you integrate the velocity, you get the displacement, but it's also another antiderivative. So you obtain a new constant d. How to find d? Well, you plug in the initial displacement to find d. Okay, so let's look at example 1. Solve the initial value problem. Okay, so we're given y prime how to get y. So y of t is integral of y prime of t, which is integral 10 e to the minus t over 2 dt. Okay? So how do we integrate that? Well, do you remember the formula? The formula for integral of e to the kx dx is e to the kx. What do? Do we multiply by k or we divide it by k? Yes, we divide it by k. So when we differentiate, we multiply by k, and when we integrate, we divide it by k. Okay, so this is 10 constant multiple stays here. And then we have e to the minus t over 2. What is the k? The k is minus half, right? So, and don't forget our cell phone C, okay? And so divided by negative 1/2 is the same as multiplied by negative 2. So we have minus 20 e to the minus t over 2 plus c. How do we find the c? We plug in the initial condition. So what is the initial condition? Right here, y of 0 is 4. So we plug in y of 0 is 4. Okay. Oops. That equals, when we plug in t is 0, we get negative 20. E to the 0 is actually 1, it's not 0. Plus c, so we see c equals to, okay, c equals to 4 plus 20, that is 24. Alright, so after we figure out the c, y of t is then minus 20 e to the minus t over 2 plus c is 24. So this is how we solve the differential equation. Okay? Alright, next. What is a separable first order differential equation? So we talk about the definition of differential equation. We talk about the definition of order. So what is separable? So separable equation is a first order differential equation that can be written in the form of dy dx is on the left hand side, and the right hand side you can see is a product of function of x and function of y. So it's like you can separate the x and y. So you get products, and then g only contains x, the f only contains y. Okay? Yeah, so on the right hand side we can separate the function and the function of x and function of y. And furthermore, if f of y is not 0, we can actually both sides divided by f of y, and then we can move the y to the left hand side. Okay, all the y are on the left hand side, all the x is on the other side. Then we can integrate both sides separately. Okay. Oops. All right. So let's look at example 2. Solve the initial value problem. Okay. So you can see on the right hand side, this is a function of y. This is function of x. So it's already separated, right? We have a product. Okay. So what do is we divide it by the function of y on both sides so that we can move the y to the left hand side. So let's divide it by cosine squared 3y. Okay, so we divide it by that. And then on the right hand side, what do we get for the right hand side? The right hand side, we still have e to the minus x plus 7x. Okay, and then on the left we have dy. So you can imagine we can both sides multiply by dx. So then dx is on the right hand side. See? Now we have moved all the y to the left hand side, and we move all the x to the right hand side. We're ready to integrate them. So when we integrate them, what is the left hand side? 1 over cosine is secant. So we get secant squared of 3y. Integral of secant squared of 3y. And then on the right hand side, we have integral of e to the minus x. We know that is e to the minus x divided by minus 1. So we have negative. And integral of 7x is 7 over 2x squared, right? And then we do plus c. Okay, so let's continue of the left hand side. Do you know what is the integral of secant squared? Yeah, so pause the video and think about it. All right, then answer me. That is tangent, right? So it's tangent 3y, but because of the u substitution, your u is actually 3y, right? So, let me use a different color to indicate. So this is like our u. Du is 3 dy, but you need to put the 1/3 in front of it. So that's why the integral is 1/3 tangent of u. Okay, let's continue. So we have minus e to the minus x plus 7 over 2x squared plus c. Okay, so you only need to plus c on one hand side. You don't need to like plus 2 constants on each of the side. Okay, well, why is that? Imagine if you have like a constant d here, and then there you have a c. You can move the d to the right hand side. You get c minus d, right? And then it's just like a new constant. You can just rename a constant to be e. So that's why you only need to add the constant on one hand side. You don't need to add on both. Okay, and so after that, because we have the initial condition, we can plug in the initial condition and figure out what c is. So let's do that. Okay, so it means y of 0 is 0, so x and y are both 0. Okay, when we plug in tangent of 0, do you remember what's tangent of 0? What's the graph of tangent? So this is 0, this is pi over 2, this is negative pi over 2. So tangent of 0 is 0. And e to the 0 is 1, so we have minus 1. So, and then x squared, 0 squared is 0. So plus c. So what do we get? We get c equals to 1. Okay, so that's why we get 1/3 tangent 3y equals minus e to the minus x plus 7 over 2x squared plus 1. Okay, all right. Sometimes we can solve a y. So like in this case, we're able to solve a y. So how do we solve a y? We can multiply both sides by 3. Then we have tangent of 3y is negative 3 e to the minus x plus 7 over 2x squared. 3 times 7 is 21 plus 3. And then, so in order to get y, we apply arctangent on both sides. X squared plus 3. And then to solve for y, we can both sides divided by 3. So 1/3 arctangent of negative 3 e to the minus x plus 21 over 2x squared plus 3. Questions? Can we cancel this 3 and those 3's? No, we can't. So this is our answer. Okay, so when the problem asks you to like solve y explicitly, then you want to express y as a function of x. Okay, but sometimes the problem asks you do not need to solve y explicitly, then it's okay to just leave your answer like that. Okay, all right, let's continue. Okay, so let's continue. So here we have the left hand side is dy over dx. Okay, and then the right hand side you can see is a quotient, but it's okay. You can see the numerator of is function of x, and the denominator is the function of y. So we can both sides multiply by the denominator. So we get 2y plus cosine 2y. Okay, that is times dy, and we have the right hand side 6 x to the 7/4 plus secant x tangent x, and then in order to get rid of the dx, so we multiply by dx on both sides, right? Okay, so now we have moved all the y to the left hand side and all the x to the right hand side. Then we're ready to integrate. What is the integral of 2y? Well, that's y squared. What's the integral of cosine? It must be sine, right? But plus sine or minus sine. So think about it. What is the derivative of sine? It's positive cosine, right? So that's why we have positive sine 2y. But because of the 2, we get 1/2 in front. And then next, we have 6 stays here. We have 6 stays here. And then how do we integrate? So we have x to the 7/4 plus 1. 7/4 plus 1 is what? 11/4. And then we divide by 11 times 4. Okay? And what is the integral of secant x tangent x? Well, that is secant x. After we finish, we plus c. Okay, so let's make it look nicer. 6 times 4 is 24 over 11, x to the 11/4 plus secant x plus c. So here, because we're not given the initial condition, so we're not able to solve for c, so it's okay, just leave it like that. And you can see in this problem, we are not able to solve y explicitly. Yeah, because we have y squared here and the sine 2y, so we're not able to solve y explicitly. So just leave it like this, okay? Example 4, we want to solve the differential equation. Well, you can see on the right hand side, we don't have a product, right? We have this guy is the function of x and y together, and this guy is a function of x, y together. So we first need to separate the x and the y. Do you know what is e to the 3x plus y? That's e to the 3x plus times e to the y, right? Okay, plus e to the y, and then this is actually x to the, what is that? 5th root. Can you see the common factor? Yes, the common factor is e to the y. Then we have e to the 3x plus x to the 1/5. Okay? And then, see, now we have a product of function of y and function of x. So let's move the y to the left-hand side. By moving, I mean divide, okay? So we divide it by e to the y, and then we multiply by dx on both sides. And then now we have moved all the y to the left-hand side and all the x to the right-hand side. We can integrate it. So on the left, this guy is actually integral of e to the minus y dy. What is the integral of e to the minus y? Is e to the minus y divided by minus 1. It's the same as multiplied by minus 1. And integral of e to the 3x is e to the 3x divided by 3. What's integral of x to the 1/5? We add 1 to the exponents, it becomes 6/5. And then we divide it by 6 multiplied by 5 and plus c. All right. So here you can see we don't have initial condition, so we can we don't need to solve for c. But if the problem asks you to solve y explicitly, so actually in this problem we are able to solve y explicitly. Okay, so how do we do it? First, we want to multiply by -1 on both sides. Oops. When we multiply by -1, all the terms become negative on the right. And then we're ready because we can take natural log, right? We take natural log and then we get -1 is natural log of -1/3 e to the 3x minus 5/6 x to the 6/5 and minus c. Okay, and then what is y? Well, I'll put minus, multiply by -1 on both sides. 5/6 x to the 6/5. Let's see. Okay, so this is our answer. All right. So far, so good, everyone. Okay. And then let's continue. So example 5. So this is like this is similar to your exam, okay? Exam problems. So we want to solve the following initial value problem. No need to express the solution explicitly, okay? So first of all, let's make sure are the x and y separated? On the right hand side, you can see we have function of x times function of y, right? Okay, so let's move all the y to the left hand side and let's move all the x to the right hand side. Okay, so how does that work? Both sides divided by e to the 7y. And then we want to move the x squared to the other side, so we use the right hand side. This is like x to the 1/3, right? Divided by x squared and multiplied by dx. Okay, what's the left? So this is e to the -7y. Okay, how about the right? Remember, we don't have quotient rule, and this is not a rational function. We cannot use partial fraction, but actually you can simplify it, right? The first term, after you split, the first term x squared cancel. So we have 4 sine 3x plus 7 x to the 1/3 over x squared. That is like x to the 1/3 minus 2. Do you know what is x to the 1/3 minus 2? That is like 1/3 minus 6/3, so -5/3. Okay, so I really hope that when you work on these problems, you can pause and try the problem first. Okay, because you're watching the videos, you can control your speed. You can try it. You can stop each steps and try it first, and then continue and check the work. Okay, so let's integrate. On the left-hand side, we have e to the -7y divided by -7. Here we have 4. Okay, what's the integral of sine? It's cosine, but plus cosine or minus cosine? Well, think about the derivative of cosine. It's negative sine. So integral of sine is negative cosine. And the 3 will actually comes in front in the denominator. Okay, 7 stays here. When you add 1 to the exponent, -5/3 plus 1 is -2/3 divided by -2 times 3 and then plus c. Okay, So that's minus 1 over 7 e to the negative 7y minus 4/3 cosine 3x. Here we have minus 21 over 2 x to the negative 2/3 plus c. Okay, and then next, because we have the initial value, so we should plug in and find what c is. So x, we plug in, x is pi and y is 0. So when we plug in y is 0, e to the 0 is 1. Cosine 3 pi, do you know what's the picture of cosine? So this is cosine, this is 2 pi. So at 3 pi is, let's see, where's 3 pi? So this is pi, 3 pi is then, here is at minus 1. So minus 1 times negative become positive. And then next, negative 21 over 2 pi to the negative 2 over 3 plus c. So c is, what is that? We get c is minus 1/3 subtract 4/3 plus 21 over 2 pi to the negative 2/3. Okay, and then let's copy it down. So the solution is, yeah, after you figure your c, you have to plug it back into the solution. That is the final step. C is minus 1 over 7 minus 4 over 3 plus 21 over 2 pi to the negative 2/3. Okay, so this is our solution. All right. So we talk about how to solve separable differential equations. The next topic is direction field. Okay. So direction field, so actually, unfortunately, it's impossible to solve most differential equations in the sense of obtaining an explicit formula for the solution. It's like, for derivative, any function, we can always find the derivative, either through combination of product rule, quotient rule, and chain rule. But for integrals, we're not able to solve most integrals. So even though we learn some integration techniques, we learn integration by parts, the trig substitution, U substitution, and partial fractions, but still we're not able to solve most kinds of integrals and get explicit formula for the antiderivatives. So same thing for differential equation. Okay, so in this session, we will show that despite the absence of an explicit solution, we can still learn a lot about the solution through a graphical approach, which is direction field. Sometimes we also call it slope field. Okay, so consider the general first order differential equation, y prime equals to f of xy. So let's call the right-hand side to be f of xy. Okay, so f is a given function of x and y. A solution of this equation has the property that at each point xy of the solution curve, the slope of the curve is the function f of xy. That is because, remember, this is a derivative. What's the derivative? Derivative is the slope of tangent line. So at each point, you can actually get the slope of the tangent line. Okay? So a direction field is a picture that shows the slope of the solution at selected points of the xy plane. Okay. So you can imagine the slope field is really like a river tube in a water park. Okay? Yeah. You can imagine. So We are in the summer and then we're in the water park. Have you been to a water park? Yes. Have you played this weaver tube? So the water is like flowing you and then you just follow the water and in a very relaxed way, okay? All right, let me put a picture here first. Okay, so let's look at example 5. So consider the initial value problem. Y prime equals to x plus y of 0 equals to 1. Okay, so how do we find the slope? Well, let's pick some points, okay? So let's consider the point 0, 0, as 0, 0. So let's look at this one. As 0, 0, when you plug in the differential equation, 0 plus 0 is 0, okay? So you know 0, what is 0? So we have 4 kinds. This kind, m is 0. This kind, m is positive. This kind, m is negative. And this kind, m is undefined. Okay, so 0, then you can draw a line segment that is horizontal. Okay, how about at the points 1, 0? At 1, 0, when you plug in y prime, you get 1 plus 0 is 1. So, can you draw a line segment with slope 1? Oh, it's like that, right? And how about at 1, 1? So 1, 1, 1 plus 1 is 2. The slope is 2. 2 is bigger. So if like this is 0, this is 1, then 2 is like that. So you can see this is like 2. Okay. How about 0, 1? When you plug in 0, 1 is also 1. How about here is minus 1, 0. Minus 1, 0 is actually minus 1, so it's like that. How about this point? Minus 1 and 1. When you add them, minus 1 plus 1 is 0. Okay? So you can see at each point of the xy plane, we can plot the points into our slope function. And then we can get the slope, then we can draw a little line segment to indicate the slope at that point. Okay? So after you do this for all the points on the xy plane, you actually get this picture. Okay? Now, let's look at our initial condition. So our initial condition y of 0 equals to 1. So where is this point? This means x is 0, y is 1. So we're at this point. So at this point, think about it. We are on the river. We are on the river tube. Follow the river. So follow the water. Here, because the slope is like that, so you know it looks like this. Here, the slope is like that, so you know it looks like this. So that's why this is what it looks like. Okay, so maybe the slope is like this, and here is here, and then you connect them. So you can see, follow this path, you won't cross this line. Okay, how about more examples? If I tell you my initial points is here, let me use a different color. Okay, so if our initial point is here, well, you can think about, when we follow this, then it looks like that, right? It looks like that. How about if my initial point is on this line? Well, if it's on this line, then we can see, oops, it goes like that, right? It's actually on the line. It just stays on the line, okay? And how about if we are on the left-hand side of the line, like here? Well, then it looks like that. Okay, so you can just think about the feeling of in the water park. Okay, so let's continue. So here are more examples. Okay, there are more examples. So given like this slope field, okay, you can see, let's say we have the initial points here. You can see, follow the arrows. then my solution curve looks like that. So we get straight lines at any point of the xy plane. Next one, if my initial point is here, then follow the arrows. It looks like that, right? How about if it's here? Oh, then it follows this path. So that's why we get a parabola. Okay. And next, what is next? Next, we have, let's say if the point is here, we follow the arrows, and it looks like that, right? But how about if we have a point here? Follow the arrows. It should be, say, constant and horizontal, right? How about below it? Or below it, follow the arrow. It looks like that. So it really depends on your initial condition. So in this picture, my initial condition is below the x-axis, then it goes down, right? Next, if my point is here, we follow the arrows, and then it looks like that, right? Okay. Next, you can see if we have a point here, follow the arrows, it looks like that. And if the point is here, follow the arrow, we should get a line, right? And if my point is here, follow the arrows, the curve looks like this. Okay? And next one, here you can, if we have an initial point here, we draw it, oh, it looks like this, right? And here, then it looks like, then if it's here, then it looks like that. Okay, can you imagine? Okay, so actually, how about here? I would say here it will stay. Okay, next. Oh, if at this point, so you can see is like this. So just follow the arrows. How about this guy? You can think about, oh, it's like this, and we go up, and then here. How about on the top? Oh, we go up and go down. How about here? We actually will stay. So it really depends on your initial points. Then we can estimate on what is the solution gonna look like. Okay. Let's continue. Example 6. Match the differential equations with its direction field. Okay. So we're gonna match them. First, y prime is 2 minus y. So how do we work on these problems is you can try to plus some points on the xy plane and then find the slope. Okay, so usually the point we pick, the easiest point, 0, 0, right? Okay, let's look at this one. 0, 0, you can see the arrow is this. So it means the slope is positive, 0, negative, or undefined. It's negative, right? The slope at 0, 0 is negative. Okay, let's look at which function. Well, the first function, when we plug in 0, we get what? 2. 2 is positive, so not this one. How about this guy? When we plug in 0, oh, when x is 0, this is 0. Oh, not this guy. How about this guy? When we plug in 0, 0, oh, we get -1. Good. Yeah. How about the fourth one? When we plug in 0, sine of 0 is 0. Also 0. Okay, so you can see we just plug in 1.00. And then we see the first one is positive, second one, and the fourth one are 0. And then the answer must be the third one. Okay? So here we just plug 1 point and then we can figure that out. Yes. So sometimes you might need to plug more points. Okay, how about here? Let's again plug in 0, 0. You can see the slope is positive. Do you remember which one is the slope is positive? Yes, the first one. Okay, because the second one and the fourth one, the slope are 0. So you can see next. Well, at 0, the slope are both 0. So we need other points. What's the difference between them? Let's find the difference. Okay. I would think about you can see the difference here around 2 and 3 here. The difference, this is negative, but around 2 and 3 this is actually positive, right? So let's plug in 2. Let's see, let's plug in no 2, so maybe 2.5 there. But 2.5 is hard to plug in. Let's try other points. Let's see. Can you see this guy? The slope is like 0 at 3. And then here, the slopes are 0 at the 3. Right? And this guy, the slope are 0 at the 2. How can I tell it's 0? Well, you see some above it is like this, the below is like that. This is positive, this is negative. Then the middle it must be 0 because the functions are continuous. So this is positive, this is negative. The middle one has to be 0. Okay, that's why I know. And here it's gonna be 0, the slope. Okay. So this guy, the slope is 0 at, this is what, y equals to 2. Wow, is this guy, right? Is 0 when x is 0 and when y equals to 2. So we know this is this guy. All right, then this one must be this guy. But let's check. You can see when to make this guy 0 is when the x is 0 or pi or minus pi, right? Well, let's look at our picture. When x is 0, do we have 0? Yes. When x is pi is around 3.14, okay? Oh, sorry that our pi day event is cancelled. Okay, and minus pi, we also get 0. Yeah, we get it. And sine y, how do we make this guy 0? When y is 0, also pi and minus pi. So you can see when y is 0 is 0. And when y is pi is like here, 3.14. So that is 0 and pi is negative pi. So, and when y is negative pi, we also get 0. And so it match with our differential equations. Okay, so you can just put some points or find a point where it's 0 or where the slope is positive or negative. Then you can see the difference between the different slope fields, and then you can match the correct differential equation. Okay, so next I want to show you, so how do I draw those slope fields? Not by hand. Okay, so how do we get those slope fields? So let me bring you to our course website. Okay, so here's our course website. So look at the extra credit projects. Yeah, we still have the extra credit projects. And for the first one, use GeoGebra to visualize the solid of rotation. Actually, 2 of you have turned in their projects and get 0.5% extra credits. So you can still turn those in. You can get at most 0.4% extra credits. Okay, and then so let's look at the second one. Use GeoGebra to draw slope field and solve ODE. So this project, here is a PDF instruction. Okay, so you can use GeoGebra online or download it on your computer. Okay, and you can please watch this video about how to draw slope fields. And so after you finish the video, I also give you a step-by-step screen shot, okay? So you can follow the screenshot and then plug in the functions. And at the end, when you are done, you can click share and then share to public, and you will get a link. So email me that link, okay? And then I can post your projects on our website. Okay, so let's look at, this is the example. Okay, you can see after you draw the slope view of the right-hand side, the function f of x, y, then you can see this is a slope field. Okay, and actually you can solve. So for some of the ODE, you're able to solve it, and then you can get the explicit formula for it. Okay, but remember, we're not able to solve most kinds of ODE, but for some of them, you're actually able to solve it. Okay. And you can also put some points, okay? And then you can also draw the solution curves. Okay, you can see, imagine here, this is our slope view. If the initial point passing through this point, then solution curve will look like that. Okay, so this project is very easy. So it is much easier than the previous one. The previous one, draw the solid of rotation is quite hard, but this one is super easy. So please work on it and email me your link. Then you will get 0.5% extra credits if you turn it in before April 19. Okay, so that's today's class. Bye.